clarify one point. I hired from the Snohomish Master Gardeners last year, so I'm giving this talk as a Floretum member, not as a Master Gardener, just so I don't get in any hot water with the Master Gardener Foundation. So first of all, I grew up in Jackson, Wyoming. It was high elevation and very dry, and there wasn't a lot of moss. So when my parents brought me here to Washington to go to the University of Washington, we took a little trip out to the peninsula, the Olympic Peninsula, and went to the Hoh Rainforest. And oh my goodness, we were amazed at the dramatic moss out there. I hope many of you have also traveled out there. It's quite lovely. I have a quote here from Marion Harthill. She wrote a book called Common Mosses of the Pacific Northwest, of the Pacific Coast, I should say. Unfortunately, it's out of print now, but her quote is, "Our Pacific Coast has the most luxuriant growth of mosses outside of the tropics." I just love that. So let's get right busy here. Are you seeing these other people, or are you just seeing the slides?
I'm seeing the slide.
Okay. Well, this is a moss plant. This is a toothpick. So it's a very small plant. They're about 1/2 inch to 3 inches long. So every tuft you see is made up of many individuals. And this is a little drawing of a moss plant. It's they have no true roots. They're non-vascular, meaning no true roots. They don't have flowers and seeds, no seeds. They just produce spores. So this little rhizoid is kind of like a holdfast. It just kind of helps it stick to the substrate. It has a leafy structure called a gametophyte. And then it has a stalk, which is the sporophyte. Moss follows alternation of generations, which means the gametophyte is only one set of chromosomes, and then the sporophyte is 2 sets of chromosomes and releases spores, which are then 2 chromosomes. We'll get to that in a few minutes, but I just thought this was a nice little drawing. So let's go on. What's the next? Today I'm going to talk a little about the ecology, morphology, reproduction, uses in history, concerns, moss garden challenges, and identification. So we talked about mosses are small, non-vascular plants. They have no xylem. Nothing is transported up the conductivity. They don't have roots, flowers, or seeds. They produce spores. Now, this is my favorite part. They live in the boundary layer where the atmosphere touches the earth. It's kind of like everywhere. It's a really dynamic layer. Think about, there's moisture there from condensation and rain, and there's decomposition and dust and nutrient transfers. And so it's just a very fascinating little area with animals and other plants, and a little moss spore lands there and can start its life. These plants are really tenacious and they're kind of opportunistic. I just love looking at moss and taking a lot of pictures of them. I think Val would appreciate looking at moss. Moisture is essential for moss. Every little part of a moss plant, the structure, is made to retain a molecule of water as long as it possibly can. Look at these gorgeous little droplets everywhere. The little leaves, everything, they want to capture moisture. That's because water flowing over the moss is necessary for photosynthesis and the absorption of nutrients, since they don't have any xylem or internal way to get nutrients. They have to get it from the water flowing over the leaves. And they also need it for sexual reproduction, which is very interesting for this little teeny plant. They also need a stable substrate, adequate sunlight, and favorable temperatures. So usually it's on the cooler side. It's, you know, this is great weather for mosses. This is a very interesting part of moss. When there's no water around, they can desiccate. It's called poikilohydry. They curl in upon themselves and they can lose up to 98% of their moisture and still survive. It's pretty amazing. This is a herbarium specimen that a bryologist took a little piece of this, added moisture. This is almost after 100 years, and made new moss. So they're called resurrection plants. I think that is just a pretty fascinating thing. And it kind of shows why they can live in a lot of places. Mosses grow on all 7 continents. They grow in extremely harsh conditions or lush conditions, as we've seen. This desiccation ability helps them, gives them an advantage, and they're very small. So here's some on the Arctic Peninsula, and here's in the shade of a cactus, which is also a moisture capturing plant. I don't know if any of you have aquariums, but this one, Taxiphyllum, the Java moss, is used in aquariums or freshwater. There are no saltwater species. They're only freshwater and land. Some mosses can tolerate the intertidal splash zone, but saltwater, I think, is reserved for the algae. Okay, some mosses are substrate specific. This one here growing on the alpine rock, these rocks probably give it a certain complement of nutrients. As the water runs over the rock, they can absorb certain minerals. This is really fascinating. I hope you can see this is a weevil. It's an actual insect, and moss is growing on its back, and the little insect uses it as a camouflage. So that's kind of a unique way to get moved around if you're a moss. This is one of my most favorite. This is moose dung moss. And yes, it is red and very beautiful. I hope you all get to see it someday. Kind of a funny thing. I don't know, a few years ago, before they took down the big Seattle viaduct, they let people walk on it for a day. And I was just kind of amazed at how much moss there was growing on the viaduct. You think about this boundary layer we're talking about. So it's up in the air, moss spores could fly in, there's dust and dirt from the road, and they find a spot and it's probably pretty moist up there. And they started colonies, and from their colonies then they could hold other little pieces of debris, and it kind of made a great accumulation. I just thought that was just fascinating. This is a northeast facing retaining wall near my house. And it's kind of hard to see, but you can tell there are different kinds of mosses, and they do compete with each other to grow. And I loved that there were little patches, I'm sorry. The little patches of bare ground here, or bare wall. I noticed that little pieces of moss would fall off of this wall and were laying on the sidewalk. And if you think about it, Okay, that little clump of moss now gets pushed along by an animal or maybe the wind or the water, and it gets a whole new spot to try and establish itself. So that is called fragmentation. And as gardeners, we need to be careful and think about that when we're getting rid of moss or moving moss. It does come apart because it's made up of so many little individuals. So fragmentation is something to think about. Okay, so how does moss fit in to the living world? When I was in school many years ago, there were 3 kingdoms of living organisms: animal, plant, and protist. Well, taxonomists just go crazy all the time, and they divide and figure out ways things fit together. And now there are 6 kingdoms, 6: animal, plant, protista, fungi, eubacteria, and archaea. So obviously fungi, you know about that one. Eubacteria are the true bacterias, and this archaea includes fossils, psychrophiles, which are the cold-tolerant little organisms that can live under the Arctic ice, and thermophiles, which are heat-tolerant. They live in the pools of Yellowstone or the deep ocean vents. Taxonomists are always discovering new organisms and how to put them into the living world. But today we're going to talk about the plant kingdom, which is divided into non-vascular plants and vascular plants. So here is where mosses are in the division Bryophyta. Down here you can see there's ferns and seed plants, and gymnosperms and angiosperms are flowering plants. But we're up here kind of at the very top. There's 3 kinds of Bryophyta: hornworts, liverworts, and then the mosses. Okay, so, this, I guess I was going to talk about this now. This is a good place to put lichens because lichens don't fit into that big chart that we just saw. They are a composite organism. And I took a quote to kind of talk about them from Microlichens of the Pacific Northwest. This is a great book if you like lichens. The quote is, "A lichen consists of a fungus and its photosynthetic partner, a green algae or a cyanobacteria, or both, growing together in a mutually controlled symbiotic relationship." So that's pretty interesting. They really couldn't fit in any one of those parts of the chart we just saw. Lichens are named after their fungal partner. The alga or bacteria living within them do the photosynthesis and help with producing the sugars that sustain the fungus in return for being sheltered. So there's no spores, I don't know. They're interesting, and they usually occur with mosses. So hopefully one day we'll get a lichenologist who will come and give us a great talk, a little more about them. In the meantime, there's several books out there you can kind of poke around and try to decide which lichens you have growing on your trees near your mosses. Okay, the first mosses, bryophytes, the first bryophytes were probably liverworts, and they came out of the ocean in the Ordovician period, kind of back by the trilobites. They're lobed, they're kind of like algae. This one is this liverwort. It's just kind of slimy looking, and I don't really see any of the sporophytes on this one. So I just wanted you to know they're very old. what are the differences between the mosses, liverworts, and hornworts? Well, mosses have that thin stem and simple leaves and a midrib in that called a costa. They have an elongated stalk with a little capsule at the tip. Liverworts are kind of phallic, leafy stems, and often their little sporophytes have a lobed capsule. Hornworts have irregular bodies and they're little hollow stems of the sporophyte, so hornworts. This is a liverwort up close from a very powerful magnification. Those cute little, almost like a little umbrella. And then the hornworts just are little hollow capsules. Just the sporophytes are just little capsules, just for fun. Mosses, by the way, compose the biggest part of the bryophytes. There are 12,000 species or more of mosses in the world, and get this, 900 species are right here in northwestern North America. So they're very prolific. This is going to be fun. This is the life cycle. Okay, the life cycle of a moss. I told you they were alternation of generations, which means they go from the two sets of chromosomes down here, the little spore, it lands, it creates a little mass of stringy things called a proteinema. That creates a miracle, a little gametophyte leafy thing here. Let me look at my notes. I'm so sorry.
I'm trying to get on. I had a problem with Fred, but I'll see if I can get on. Thank you.
Okay, so we've got the spore, made this little bunch of massive little stems, and from those become female and male gametophytes. So these have just one set of chromosomes. Okay, so the male actually produces sperm, and the female has like a little egg cell and a little tube called a venter. So when it's nice and wet, the little sperm actually swims, they have flagellum, down the little neck and fertilizes the top of the female and becomes zygote and creates then on top of the female this sporophyte. So the sporophyte has a little capsule and a little operculum inside that is like a little bunch of teeth that turn and release the spores. So when the conditions are right, the spores come out and it starts over. So we have, these are all just one set of chromosomes. And then the sporophyte is two sets of chromosomes after sexual reproduction. So pretty complicated, cute little things. Here are some of the little capsules and sporophytes. This is, okay, there's this little covering called the calptra, and it breaks away and opens up the capsule, and then the little operculum, which is like a little door, comes off and the spores come out. And this little peristome is what I was talking about. The spores are in here. Look at this amazing little, I don't know. This is a high-powered part of from a microscope, but there's the little spores and it just shoots them out from this little whirling peristome. Isn't that cool? This is kind of hard. I'm not getting any feedback from anybody, so I hope you're following okay. So now you want to get into the meat of what are mosses good for. Well, ecological, historical, medical. The first one, all bryophytes play a significant role in boreal, montane, and northern ecosystems. When you think about our Pacific Northwest and all the rain we get, what do mosses do? As they cover the trees, they capture that moisture and slow it down, and they can help take care of erosion and just help make the nutrient cycling better for our forests. Okay, so what is a bioindicator of pollution? They're very sensitive. So when you see your mosses starting to die, sometimes like factory emissions or acid rain or wastewater treatment water, these kind of things can help us know, moss can help us know that there's some serious pollution. They can also colonize burned or disturbed areas. They're kind of the first thing to come back. I guess, well, if you think about it, wind could blow them around pretty easily and transport them, or animals or other things. Anyway, those are some of the ecological good things moss do for us. Historically, they've been used for fuel, packing material, bandages, diapers, dyes. So there's a lot of things that dry moss can be used for. And now we know from Val that they can be certainly used for very decorative things, beautiful, beautiful arrangements. In the medical field, some biotechnologists in Germany have developed a moss into a safe and inexpensive supplier of medicine, creating a human protein in a moss instead of using an animal cell line. Now, I'm not really sure how all of that works, but these human proteins then are distilled out and can be used to help diabetics and macular degeneration without using an animal cell line. So that's pretty exciting. There's also a group of scientists in Switzerland who are working on a liverwort that produces a cannabinoid compound. So it mimics the pain-killing abilities of the cannabis, medical marijuana kind of relief. And so that's coming from a moss. It's just kind of fascinating. So they're also good for moss gardening, which we'll get into in a few minutes. And the soil amendments. Well, I want to talk a little about peat. So let's get going on those. I know many of you are very interested in moss gardening. And I am not an expert on moss gardening or what mosses to use. And I want to urge you, if you're very interested in it, this is a picture of our Dung garden, which is just down the road in Shoreline. This is from the Blodell Reserve in Bainbridge Island. And this nice little teeny moss garden from McCullough Valley Nursery in Snohomish, I kind of like this one myself. If you notice, there's a lot of debris on these other big moss gardens. This one looks pretty easy. Part of the reason I don't think there's any overhead trees dropping moss or dropping leaves and stuff on it, but it's still very beautiful. Of some of the books that I have touched on, there are two main things for moss gardening. The first is keeping moisture. Obviously, we need moisture for moss. And that can be hard to keep it watered. The second thing is keeping weeds and debris and plant material out of the garden or off the surface. And you can't really rake moss, it's too delicate. So you kind of have to hand pick it or maybe use a leaf blower. That's one of the biggest problems. So something to think about. Let's get into peat moss. Sphagnum moss, known as peat, is a true moss. This is where peat moss comes from. So it's kind of a hard thing to think about. Oh, just a second. I think I'm a little out of order in my talk here. Canada produces quite a bit of our moss, our peat moss. And, you know, it's kind of hard. Moss, as we know, grows about 1/2 inch a year. And a big peat bog, when you strip it off, you know, the first top layers, it's going to take 10 to 15 years to recover and become a bog again. So Canada grows about 25% of the world's peat moss. And they just strip it off, you know, bag it up and sell it to us. And they say it's a sustainable resource, but is it really? We need to be very careful to think about that aspect of sphagnum moss. So here's some alternatives: compost, cocoa coir, pine bark nuggets, peat moss or paper fibers, rice hulls, and worm castings. But if you're going to be using these different alternative absorbing materials, kind of you have to think about, do a little research, or not research, but experimenting to see how well they will keep the moisture compared to your sphagnum moss. But it's worth a try, thinking of these huge areas that they're taking apart up in Canada. It's just kind of mind-boggling. We have a bog in Snohomish County called Hoven Bog. This is 522 and Maltby. It's just this big bog down here. So there's a couple of other bogs. Mercer Slough has a bog. Part of Martha Lake has a peat bog. There's the Ink Blot Nature Area preserved down in Shelton. If you search peat bogs at the Washington DNR site, you'll come up with quite a few. It's really interesting. I don't think you can go and tour this bog. It's just protected, but I thought that was really interesting that we have one right here in Snohomish County. So one of the biggest problems we all have is moss in your lawn. Eliminating conditions that favor moss is the most important thing. You know, look at your lawn. Where is your moss? It's probably in the shady area that's really wet. Maybe there's drainage. You know, you didn't plant the right grass seeds, so it's sparse, and moss can just really take over. Often, to get rid of moss, the best way is to use a product that will kill it, such as, you know, Moss Out or something like that. And it turns black. Be careful, don't get that product on your sidewalks and stuff. Once the moss is turned black and dyed, you have to physically, this is the one, physically remove the moss. You got to rake it out or pull it out, or somehow you have to get it out. Remember, it can fragmentation, you know, it can just keep coming back. Then once you've got your moss out, you might want to do a soil test. You know, just make sure you maybe prune the branches above that very shady area, or amend your soil so it's more conducive to growing grass if you really want grass there. And then plant like a shade kind of grass and take care of it, fertilize it, keep it healthy. Once the grass is healthy, the moss won't be able to get in there. So remember, glyphosate has actually no effect on moss because it doesn't have any xylem. It can't take in any kind of nutrients that way. So you're wasting your time. This is really a cute way to get rid of moss. How many of you have seen these crows out in your lawn? And of course, they'll pull up the moss instead of the grass because it's a lot easier. There's no roots, so they just tear it right out. So what are they looking for? I don't know, in my neighborhood, there are crows all over pulling out the moss. It's very cute. So those crows are looking for this European Schaefer grub or cranefly larva. And so that's what they're doing, pulling your moss out of your yard. But it's kind of a fun way. I don't think you can hire crows to do a good enough job. Okay, so moss on trees, you know, it's not actually going to hurt your tree at all. The removal is aesthetic, but only do it during the dormant season. I mean, you don't want to ruin your buds or the bark. So you can leave your moss on your trees. It looks kind of nice. And as Val was showing us, there's a lot of ways it's beautiful. It doesn't really hurt anything. Garden beds, however, you really should try to get it out of your garden beds. Because, why? It will keep coming back if you don't. And it does attract moisture and retain it. And that can rob your plants that you're trying to grow. So, I just, before we go on the trees, let me just say one thing. If any of you hike, there is well, people say that moss grows on the north side of a tree. So if you're lost in the forest, you can kind of figure this out. I would suggest you take your compass the next time you're out there hiking, go to the north side of your tree and see if there's more moss. Now, why would there be more moss on the north side of the tree? It's probably damper and shadier. So give it a try. Don't take my word for it. Okay, roofs and other structures. This is a big one. You really do need to remove moss. It adds moisture and weight, and it just is not a good thing to have moss on your roof. The big thing again, though, is removing the whole cause of moss to be there, and that's the overhanging trees, which create your shade, or just it's I don't know, using a stiff brush, no pressure washing, because you don't want to add more moisture to the roof. And you've got to look at the kind of roof you have. It's very important to be careful. Oh my goodness, be careful getting the moss off your roof. Probably a good idea to hire a professional, because I don't know how many of us know someone who's fallen off the ladder when they're trying to take care of the roof. Anyway, once you get that moss off of your roof, really look at why it's there. Remove the debris. Maybe ask your neighbor if you can have their trees trimmed up if it's their neighbor's trees, but do get rid of the shade if possible. These little holdfasts that we talked about at the beginning, they really, they can kind of damage certain kinds of shingles. So you really do need to get that moss off of there. I know there's a talk about green roofs, letting moss and other plants grow on your roof. But if you think about it, that's adding a lot of weight, and you really have to do a structural kind of process to get your roof strong enough to put extra weight and moss and plants. So it's not a good idea to just let it grow and be beautiful. Whoopsie, I think we went too far. So collecting mosses is a big deal. Florists and landscape people go into the forest, into our national forests, and use the sources of material, including moss. I checked into this, and you do need a Forest Service permit to collect large amounts of product. They're available at the district offices, but they're limited. They have to protect the resources and the collectors. So if you want to collect moss or salal, or I don't know anything about mushrooms, or that could be in there too, it's important to go to the Forest Service website and look up special forest products here and check out what the permits are and when they're available. So some of the earliest moss collectors were these amazing naturalists who came in the early days. Archibald Menzies, he was a naturalist and surgeon on Captain Vancouver's ship in 1792. He has 2 mosses named after him. So these are hard to pronounce. So Menzies, I'm just going to say, here's his name, Menzies, and here's his name again. So he was in 1792. Thomas Drummond was a Scottish botanist under the command of Captain John Franklin on the Second Land Arctic Expedition. He has one named after him here. David Douglas, I'm sure you've all heard of David Douglas. He collected all over the Rockies in 1826, and his namesake is Mckenna Douglasi. Okay, David Lyle collected extensively between 1858 and 1861 during a survey of the 49th parallel. He has a nice little moss named after him. I think the thing I find amazing about these guys, they came out and saw these beautiful big trees and all these different shrubs and ferns and all these other plants, but they took the time to collect mosses and name them or describe them. And these original moss collections, specimens, ended up in the Kew Garden in England. So mosses are important. I just think that's pretty cool. Okay, so how are we doing here? I don't want to keep you too long. Not all plants that say moss are true mosses. You go to Sky Nursery or, Home Depot and they say moss. Well, they're not all moss. Spanish moss is in the bromelid family. Scotch moss, which is a very pretty little thing, is in the carnation family. Reindeer moss is a lichen, and Irish moss is a red algae. Now, if you remember back to what we were talking about with mosses, if a plant you buy has roots or flowers, it's not a moss. There are 2, club moss and spike moss. They're everywhere. These are vascular plants, Lycopodium and Selaginella. They're beautiful and they're sold as club moss and spike moss, but they're not true mosses. All right, I just thought you might want to learn the one biggest fun thing about moss. It has 2 forms, the growth habits. Okay, this one is called Archocorpus. It's upright, and the Sporophyte comes right out of the, sorry. Comes right out of the end, okay? Emerges from the tip of the plant. They're unbranched. Pleurocarpus are prostrate and freely branching, and the little sporophytes emerge from the mid-stem. So if you want to begin to collect mosses and identify them, you're already halfway there. You can decide if it's Acrocarpus or Pleurocarpus. So this is just already, you've eliminated half of. So magnification, magnification is essential. They're so small. And a good resource with photos and drawing and often a description of where they grow. That's really important. They talk about leaf shape, smooth or toothed, opaque or transparent, and they talk about those little sporophytes, the stalks. So one of the best books I use is this one, Plants of the Pacific Northwest Coast by Pojar and Mckenna. And this is the reason I like this book. Here's a page about bentleaf moss. It has a drawing which shows you that this is what? This is the Pleurocarpus. It's branching and the little sporophytes come from the mid. It has a picture of the tiny little leaf. Tells you where it grows. And this is the best part. This says it's a common yardweed of Vancouver and Seattle. So if I found this in my yard, I'd think, aha, I'm on the right track. This is probably what I have. So this is a good book. After you kind of look at the ecology and these others, you can kind of begin to identify your moss. So the other reference that's very good for moss identification is by the mountaineers. They have a moss identification chart, and I've listed that reference in my bibliography, which I believe will be posted, the bibliography of all these wonderful books, on the Floretum website when we get it up and going. So you can download it and look at more references. So this is my last slide. This is Boulder Creek, and this is all moss in here. I just want you to remember moss needs moisture. And as you get out there and enjoy looking at these beautiful little plants, I hope you'll remember some of the things from this talk. Thank you.